Hello everyone. Today we will solve another 25 traffic engineering problems for the PTOE exam. So let's start. The first question is, although crash involvement rates, crashes per 100,000 population, are highest for the 5 to 15-year old pedestrians, pedestrian fatality rates are highest for what age groups? So pedestrian fatality rates are highest for what age groups? Although crash involvement rates, you need to remember this also. Okay, in some problems in PTOA this may come. So crash involvement rate is highest for 5 to 15-year old pedestrians. Okay, so the pedestrian fatality rate, but the fatality rates for pedestrian is highest for age group 70 years and above. So this will be option D. So let's move to the next question. Conversion of two-way street to one-way flow, basically two-way street to one-way street, can reduce which type of crashes? So it will reduce like pedestrian crashes, because the pedestrians don't have to see both sides of the road. It will reduce left turn crashes, left turn head-on crashes. So basically left turn crashes, head-on crashes, rear end crashes. So basically pedestrian, left turn, head on and rear end, these four crashes gets reduced when two way is converted to one way street. Okay, so you see pedestrian, left turn, rear end, so this option is correct. It's lane change, this is not correct. uh, so yeah, so basically option A, pedestrian, left turn and rear ends. So let's move to the next problem. Of all the physical characteristics of road users, which is the most important? So always for a road user, vision is the most important characteristics. So this is should be vision. Okay. So the next problem is intersection departure side triangle should be provided for drivers entering the intersection from a stop controlled minor street. Let's say this is a major street and this is minor street. Okay. So it's saying intersection side triangle should be provided for drivers entering the intersection from a stop control minor road. What is the intersection departure side distance? For this condition, if the ASTO recommended time gap is 7.5 seconds and the design speed of the major road is 60 miles per hour. So 60 miles per hour, the what is the design speed of the major road, and the time gap for the minor road cars is 7.5 seconds. Okay, basically 7 point, basically it's saying that a minor road car will get around 7.5 seconds gap at an average, if you find the average, to kind of cross the these intersections. So basically this will be ISD. We know it's the formula is, since it's mile per hour and this is seconds, you can convert mile per hour. It will be given to you in the formula sheet, 1.47 into V for the measure. This is the speed for the major road, all right, and this is the time. This time is for the time gap for the minor street. So this will be 1.47 times 60 times 7.5. So this will come, if you do the multiplication, it is 661.5 feet, which is around 660 feet. So the answer is 660 feet. So let's go to the next problem. A 16-hour traffic count. It's saying a 16-hour traffic count. We have a 24-hour day, right? So if we do a 16-hour traffic count, usually 6 a.m. to 10 p.m. Okay, this is a 16-hour traffic count. You need to remember this also. Okay, what time duration generally a 16-hour traffic count consists of? Normally accounts for what percentage of daily traffic on a roadway. So if you do a 16-hour traffic count, you will more or less cover 90 to 95% of the AADT daily traffic. All right. So 90 to 95% of the daily traffic you will cover in a 16-hour traffic count. So this has been asked. So this is number C. These are all straightforward questions. Okay. So next question is, when calculating stopping side distance, what does Ashto Green Book use as a deceleration rate? So Ashto Green Book for a deceleration rate use as 11.2 feet per second square. But you need to remember one more thing. But this Ashto uses 11.2 seconds feet per second square, feet per second square. But the ITE book uses, you will find this ITE when you will calculate the change, CP basically. That is a change period, right? Yellow plus all red. So when you will calculate it from the it, there the deceleration rate that is used is 10 feet per second square. Okay, you need to remember this because you will need it. If a problem asks you to calculate CP, which you have to do from it method, then you have to use deceleration as 10 feet per second square. But let's say you are calculating stopping side distance or anything like that from the Ashto book, you have to use deceleration rate as 11.2 feet per second square. Okay. And another thing, let me also tell it when I'm discussing this. Even Ashto, let's say you are calculating stopping side distance. Here the perception time t, Ashto uses as 2.5 seconds. But similarly, the time used by ITE when calculating CP, the T initial time, reaction time, that is they use it as 1 second. Okay, so the reaction time used by IT is as 1 second, and the perception reaction time used by SSD is 2.5 seconds. So let's move to the next question. When a lawsuit is filed against a public agency, consultant, or contractor related to a traffic crash, the claim is frequently one of negligence. The term negligence means. What does negligence means in such cases when somebody files a lawsuit against agency, consultant, or a contractor? Okay, whoever is involved in the project. So it's like failure to ensure the safety of the roadway, no. Failure to correct high hazard locations, no. Failure to remove roadside obstacles, no. Negligence means failure to do what an ordinary, reasonably prudent person would do under similar circumstances. So basically, D will be the answer. So somebody can actually sue the agency for even for these purposes, failure to remove roadside obstacles. If, let's say, but in this question it has been asked what is negligence. But failure to remove roadside obstacles, let's say there has been roadside obstacles for 1 year, or there is a record that somebody or many people have complained the agency against that roadside obstacles for, right, and still they fail to act on it. On those cases, yes, they can sue the agency for this failure to remove roadside obstacles. But generally it's of negligence, and negligence means failure to do what an ordinary, reasonably prudent person would do under similar circumstances. So next question. If a crest vertical curve has a k value, crest vertical curve, like vertical curve is like this, k value is given as 250, and the algebraic difference of grade A is given as 5%. What is the length of the vertical curve? So you all know L should be k times A. This constant times the algebraic difference. So k is 250 and A is 5. So if this is percentage and k is just constant, you will get it in feet, which is 1250 feet. So this will be the answer. So the next problem, the US Manual of Uniform Traffic Control Device specifies that traffic control signal yellow change intervals. Change intervals means yellow plus all red. So yellow plus all red should be, the MUTCD says the yellow plus all red should be between 3 to 6 seconds. So answer C. Next question, which of the following statements about pedestrian hybrid beacon is true? So pedestrian hybrid beacon is like this. Two signal will be like this and one will be like this. Okay. So basically this will be red, these are red, and this one is yellow. Okay, so basically it will be yellow for most of the times when there is no pedestrian to cross, but as soon as somebody pushes the pedestrian button, then this with this two red two will start to flash. That means the pedestrian can cross at that time, right? So basically, a pedestrian hybrid beacon shall not be installed at location. Which of the following statement about pedestrian hybrid beacons is true? Let's see. Pedestrian hybrid beacons shall not be installed at locations where vehicle speeds exceeds 30 miles per hour. Not true. It can be installed. A flashing yellow indication shall be displayed continuously unless the pedestrian push button is activated. Yes, this is true. The flashing yellow will be there unless there is, because it has been installed. The reason is there are pedestrians for sure. That's why it has been installed, but it's not like continuous flow of pedestrian is there. So whenever there will be pedestrian, this until and unless there is pedestrian, this flashing yellow will always be there. Then the next, so this is true. The third is a beacon face shall consist of two signal sections. No, you see, we have drawn it three signal sections. And the fourth is a pedestrian signal head shall be installed at each end of the marked crosswalk. So I did a little bit research on this question. It looks like yeah, I did a wrong mistake here. So this is not the correct answer. So for a pedestrian hybrid beacons, it was like the pedestrian hybrid beacons will be looking like this. There are three signal heads, and on both sides of the crosswalk, like let's say this is a crosswalk. Just one second. There is a crosswalk here. Let's say there is a crosswalk here, and on both sides of the crosswalk, you will find these signals. You will find two pedestrian signals here, one pedestrian signal here, and one pedestrian signal here. So you will find two pedestrian signals. Okay, so those pedestrian signal heads shall be installed at each end of the marked crosswalk. And how it will work? Basically, this hybrid beacon, how will it work? So until and unless there is no pedestrian on both sides, this will be just blank, dark. Nothing will be there. All right. So the cars can just go on passing. But let's say somebody came here and pushed this pedestrian button on this pole. At that time, this yellow one which starts to flash yellow. After that, it turns to a solid yellow, and then when this pedestrian signal lights gives a clear uh, signal to pass the crosswalk, to cross the crosswalk, these two signal heads above, traffic signal heads, they start to flash red. So this is how it works basically. So this is not answer B. This is a pedestrian signal head shall be installed at each end of the marked crosswalk. All right. So let's move to the next problem. According to Astro Roadside Design Guide, design options for treating roadside obstacles in order of preference. So what is that order of preference? First we want to remove the roadside obstacle. So that should be the first one. I mean, I'm just, and you need to actually remember it. I'm trying to just make you understand, trying to show you a way it will be easier for you to remember. But this is already given by Ashto, right? It's not that I'm inventing anything. So Ashto has said what should be the order of preference for treating roadside obstacles. The first preference Ashto gave is to remove the obstacle. Just remove it. The next one Ashto actually gave is to redesign the obstacles. Okay, so the next one is redesign the obstacles so that it can be safely traversed. Okay, that is the second one. So first one Ashto gave is remove, then is redesign. The third one Ashto says relocate. If you cannot remove it completely, if you can relocate the relocate the obstacles, that will also work. And the fourth one is it said reduce the impact severity by using breakaway device. Reduce by breakaway device. This is the fourth order of preference for an obstacles by given by ASTO. Okay, and the fifth one is, if you cannot do any of the four, then just shield it, shield the obstacle. And the last one is delineate. So delineate the obstacle. So in our question, you see which is in the order of preference. Remove is first, relocate, okay, relocate, make breakaway, which is reduce, and shield with longitudinal, shield with longitudinal. This preference order is seems to be right. The next one they have given relocate before remove. Remove should be the first one always, right? Again here remove is in the last one. Here remove is first, but shield is second. Shield is just before the last one is shield. Much before that is relocate. Relocate should be here. So basically option A is the correct answer for 36. So the next question is, which of the following is a requirement of the US MUTCD devices? Requirement. Pedestrian warning signs shall be fluorescent yellow green. Yes, this is a requirement. So the others one is not a requirement but a recommendations. The other three are actually recommendations, but this is a requirement. But this is not even a recommendation. The lettering for names of places and streets on guide signs shall be combination of lowercase letters with initial uppercase letters. This is true, but not uppercase letters. Only the first letter will be uppercase and then followed by a lowercase letters, which is two-third height of the up initial uppercase letter. Okay, that's being given in the MUTCD. So the next problem is, the following 15-minute volumes were recorded in a traffic count. What is the peak hour factor? So the peak hour factor, you the volume count. What are the volume counts? 300 plus 400 plus 500 plus 300. Right? This is the total volume, and you have to find the PHF, peak hour factor. So basically, then you have to divide the total volume by 4 times the maximum volume, maximum 15-minute volume time, which is here in this case 500. Right? 500 is the maximum. So from here you will get it as 0.75. So 0.75 will be your answer. So the next question is 39. For a lane group with two lanes on an approach to a signalized intersection, if the adjusted saturation flow rate is 1700 vehicles per hour plus lane, and an effective time is 30 seconds out of a cycle length of 80 seconds, what is the capacity of the lane group? What is the capacity? It's saying per lane it's 1700 vehicles per hour per lane, but it is the adjusted saturation flow rate. I think you know what is flow rate, right? Saturation flow rate is given as 1700. Effective time is 30 seconds out of a cycle of 80 seconds. So basically, this should be in the ratio 30 divided by 80, right? And this is given as per lane, but for a lane group, you have two lanes, and they have asked the capacity of the lane group, so you have to multiply by 2, right? So from here, you will get it as 1275 vehicles per hour. So this is the answer. The next question, the ASTO Green Book recommends using what value of perception reaction time for calculating stopping sign distance? I discussed it before only. For ASTO, perception reaction times is 2.5 seconds, and for ITE, the reaction time is 1 second. So under base conditions, what is generally considered to be a freeway capacity? Freeway capacity under base condition is 2250 to 2400 passenger cars per hour per lane. Now they are doing a spot speed study, a sample study of how many vehicles is generally considered reliable under most circumstances. So under most circumstances in a spot speed study, 100 vehicles per lane is enough. So the next problem is, for an approach to a signalized intersection with a posted speed limit of 40 miles per hour, a cross street width of 70 feet and level grade, what is the minimum total change period by the IT procedure? So this is the initial, the reaction time is 1, as I said. For by the IT method, you will find the formula will be always given to you, right? So don't worry about it too much. And this should be 1.47 times v by 2a plus, and the all rate time. What will be the all rate time? This formula will be given, but still I'm trying to make you understand one thing. The the cross street width is basically the cross street width is given as 70 feet, and is given 40 cross street of 70. Okay, so the you can consider the vehicle length as 20. So the total distance 70 plus 20, it will finish 70 plus 20, the all rate, divided by what? Speed. The distance by speed gives the time, right? So speed is given as 40 miles per hour. So you can do divide by 40. And since it's in miles per hour, you can convert it to 1.47, right? So from here, you will get it as 5.47 seconds, which is nearly 5.5 seconds. So if you see the PTOE formula book, they will give you the formula for this change period, which is yellow change per plus red change clearance intervals. So for red, the total width of the intersections, how much time it will take to pass the car. Let's say the car is here, it wants to pass the intersection. So it will be the total width of the intersection plus the length of the car, which is considered as 20 feet, divided by the speed. So that's how we found this. And this is the initial reaction time. So that's why this is the 1 second, and this is 1.47 V by 2A. Right? This is the for the yellow change. So this answer will be 5.5 seconds. The next is in a temporary traffic control zone, the length of the taper to close a single lane on a freeway with a prevailing speed of 70 miles per hour. Okay, 70 miles per hour and a 12-foot lane. So width is given as 12 feet. So since V is greater than 70, so the taper length, so the length will be WS. And you have to remember, this is very important. If V is less than 45, basically V is from 40 and less, then the taper length will be WS square by 60. But here you see V is 70. V is 70. It's much greater than 45, right? It's 45 and above. So you have at that time you have to use this formula WS. So here your W is 12-foot lane and your speed is 70. So from here, if you put, you will get it as 840 feet. The next question is, when designing a curve on a road with a design speed of 70 miles per hour and a maximum super elevation rate of 6% and a side friction of 0.10, what is the minimum radius that can be used for the design speed? So for this problem, they have given you what is the interaction between friction, uh, super elevation, and velocity and radius. So there is this relation 0.01 e plus f equals v square by 15 r. All are in US units. So here you have given 0.01, e is given as what? 0.10, f is given as what? 6%, and this is v square. V square is 70 square divided by 15 times r. So you have to find the what is the minimum radius. So from here R you will get it as 2040 feet. The next problem is the most commonly used form of traffic calming. This should be speed humps. Speed humps is the most common use of traffic calming. So next problem, let's move to the next problem. When more Then one countermeasures are being considered for implementation at a problem location, like different countermeasures. Let's say add left turn the pavement marking, change the pavement marking, let's say restripe the crosswalks. So all these countermeasures are being considered for implementation at a problem location. Now they have given some examples also, both adding a left turn lane and signalizing an intersection. The crash modification factors for the individual intersections. What happens is, it's you have to multiply together the crash modification factors. It's like CMF1, let's say crash modification factor, this is for 1 times CMF2, all this becomes the final crash modification factor. From here you predict the crashes through this way, right? So number 48, purple pavement markings may be used to supplement lane line or edge line markings. Purple pavement markings, where does it used? It gets used at electronic toll collection lanes. So for high occupancy collection lanes, I hope you already know diamond shape is used. Okay, that is reserved for high occupancy vehicle lanes. And pavement, yes, purple pavement markings can be used to supplement lane lines and or edge lines for electronic toll collection lanes. So number 49 is the most effective means of prohibiting left turns access into driveways. Let's say this is a driveway. This is a driveway and we want to reduce left turns like this. So what you can do, you can build a pork chop like this. Just build a pork chop. Then this left turners cannot go in easily, right? It is not even allowed basically. But still, if I'm saying, it's not that easy to take a left turn also. And but if when you do a pork chop, it's not allowed. That's the first thing. So the effective means of prohibiting left turns in, provide a pork chop like this, the way I've drawn here. Provide a pork chop and make it like right in, right out. So answer is pork chop island in driveway entrance. The last question is, what is a primary function of a traffic signal? So yes, traffic signals has a lot of functions. It can reduce the capacity, increase the delay, reduce the delay, increase the capacity of the intersections, or maybe reduce the crashes, improve safety. But the primary reason is, let's say this is the intersection, this is a major road and this is minor. So we want the major road also to pass cross this intersection and even the minor road cars to cross these intersections. So that's why the first primary function of traffic signal is to alternatively assign the right of way to various traffic movements at an intersections. So that is a primary reason of a traffic signals. So this is the end of the today's session. Hope you guys enjoyed it. In case you enjoyed this, please like the video. And we will also do a class on what you need to study for PTOE, what you can expect at PTOE exams. So those we will study in another session. All right. So hope this is useful to you guys. In case you find it beneficial, please consider liking our videos and sharing our videos. Thank you so much. Have a great day. Bye.